Okay, we were solving the problems on Newton's laws. Next question. Okay, find the acceleration of the system and the tension T. This is 2 kg and say this is 4 kg. Okay, and if required, you can take G as 10 meter per second square. This is the given data, and since nothing is mentioned about the surfaces, right? All the surfaces, wherever there is a contact, you can consider that to be a very smooth surface, right? You can neglect the friction. And also there is another concept that is related to the string, right? So if the string is not what you call extensible, it is inextensible, which means when you put force, there is no expansion that is happening with the string. Anyway, so those concepts are not mentioned here, so you don't have to worry anything about that, right? The ideal string is massless. There is no mass, because if you have mass into acceleration, that comes into picture. So we assume that the spring is massless and inextensible, right? So anyway, normally, so what is the acceleration of the system and what is the tension in this string, right? So this is going to feel a force in this way, that's the tension. So this is going to feel the same force upwards, so that's the T, right? So anywhere you can mark, even you can mark T like this and this, doesn't matter. It's okay, that's fine. Okay, now let us assume that there is these are the T, right? Tensions. Question is to find the tension T and the acceleration of the system. Okay, now acceleration, whenever it's not straightforward, we always prefer to use the net force, net pulling force by total mass, right? So net pulling force, I'll write summation F. Now it can be in any direction. It doesn't matter, X or Y, divided by the total mass M. So net pulling force, right, of this whole system is just because of the 4 kg mass. This is the one which is actually pulling the system, right? There is no force that is inbuilt because of this 2 kg. Only this 4 kg is the one which is responsible for pulling the whole system downwards. So what is the pulling force, right? Pulling force is force into the acceleration. Acceleration is it's due to gravity. So I'll write F just for your reference. This is pulling, total pulling force. Wherever there is a pulling force, wherever the force that acts naturally, you have to write that. So in this case, it is 4 into 10. That's all. Pulling force is 4 into 10. And what is the total mass? Now, total mass is 4 and 2, right? The overall force that whatever acts here, the pulling force acts on the 4 plus 2 kg, right? So this is 4 plus 2, that is 6. So this is 40 by 6. So it is 20 by 3, whatever, meter per second square. Okay, this is the acceleration. Remember, whenever we write acceleration, net pulling force or total pulling force divided by the total mass. Okay, right? If a object does not contribute, right, to the force acting on the system, such as the 2 kg which is here, right, you don't have to write it. Okay, then for finding out the tension, you can use either the 2 kg, right, string, or the other one, right? Anyone you want, you can find out. You can use it, right? So both will give you the same answer. I will go with the free body diagram of the 4 kg mass. Say this is the 4 kg body, and I can see that there is a tension which pulls it upwards, and there is its own weight, right? So weight is equal to how much? That is 4 into 10, so that is 40. And there is an acceleration. I know that acceleration is this way. So what is the equation? This is 40 minus, right? You can do it in any way, right? You can take upwards positive, that is t minus 40 is equal to mass into that. So even if I reverse it, 40 minus t is equal to 4a, right? So 44 into a, that is equal to 4 into 20 by 3, 80 by 3. So solving that, 40, this is t is equal to 40 minus 80 by 3, right? So that is 40 by 3 newtons. Okay, yes, this is the right answer which we have. Okay, another question. This is 2.5 kg, 5.8 kg, 11.76 kilograms, and this is 8.35 kgs. So find the tensions T1, T2, and T3 of the system. Okay, so when we solve this, we get the acceleration A is equal to 0.07 meter per second square. Yes, there. T1 equal to, right, T2, okay, T3, right. Okay. Let's proceed further. The next question. Okay, so this is 1 kg, 3 kg, and say 2 kgs. Okay. Now, again, the question remains same. What is the acceleration and what are the various tensions present along the strings? Okay, so I'll call the tension over here as T1 and the tension over here as T2. So what is T1 and what is the value of T2 is the question. In this particular problem, the net force is not calculated directly because of the angles present, right? So previously the objects were freely moving. Now they are going to move on surfaces, and the surfaces are tilted with respect to x-axis. So first let us calculate the net force or the net pulling force equals to, so it is very clear that towards one side, what is the direction of acceleration? Acceleration is this way, right? So this is the direction of acceleration, because 3 plus 1, 4 kg weight is on one side, 2 kg is on the other side. So in order to calculate acceleration, I need net pulling force divided by the total mass. So net pulling force, the summation F, I'll say pull, is equal to, everything is moving on one side. This tries to, right, actually pull it this way, but the 2 kg is trying to pull it on the other side, but the force is less. That's why the total acceleration comes to the same side as that of the 3 plus 1, 4 kg mass. So now normally what we'll do, we'll try to write the mass into acceleration, in this case acceleration due to gravity. So for a 1 kg mass, this is 1 into 10. That is a normal case if at all it is coming downwards. But you see, it is not coming downwards, it is moving this way, right? So the 1 kg is moving, making an angle like this, right? So you can calculate how much is that angle, right, with which it is shifting. Otherwise, you can simply use that, right? Without calculating that, you can use this angle, right? The vertical component is nothing but the sine ratio, right? So 60 degrees given, I can simply multiply by sine of 60. 1 into 10 sine 60, plus the next mass is 3 into 10 is the acceleration due to gravity into sine 60. Okay, that's the force that is on one side. Other side you subtract. Okay, so minus 2 mass 10 into, now you see it is sine of 30 degrees, because other side you have an angle given that is 30 degrees. Okay, so simplify this to get the total pulling force. So this comes to be equal to 24.64. Okay, so many newtons. Right, now you want to calculate the acceleration, right? So acceleration is equal to force, net pulling force, that is 24.64 divided by the total mass. Mass still remains same. Every mass you need to add. So 1 plus 3 plus 2 is 6. Okay, approximately 4.1 something. Okay, meter per second square. Now we need to apply the free body diagram corresponding to, okay, let's do with 1 kg so that we can calculate. So this is the surface over which we have placed the 1 kg mass, and there is a tension here which is marked as T1, and this is the direction in which it is moving, but normally the mass, the weight acts downwards. Okay, so this is 1 into 10 Newton, right? So this becomes 10 sine 60, and the acceleration is like this, right? So we can write an equation. This means uh, m into g, that is 10 sine 60 minus t1 is equal to mass, that is 1, into the acceleration, which is 4. So which means T1 becomes equal to 4.56 newtons. Right. Very similar to this, we can write the free body diagram of the other object. That is, it's like this. So this is 2 kg. So you can see that there is a T2 marked in this direction, T2. Acceleration is also in this direction, that is A. And the weight acts like this. So 2 into 10, that is 20, right? This is the 20 Newton force which acts downwards, but we need in this direction. So since the angle is given as 30 degree, this is 20 sine 30. Okay, so this is the total testing. So we can write now the T2 minus 20 sine 30 is equal to, so the weight, which is 2, into the acceleration. Acceleration was 4.1. So T2 is equal to 18.2, I guess. Okay, 18.2 newtons. Perfect. Okay, another question. 3.6 kg, 2.1 kg, 7.17 kg, and this is 4.36 kgs. Question is to find the tensions T1, T2, and T3 of this given system. Okay, when we solve this, we get acceleration A is equal to 0.701 meter per second square. All right, T1 equals to, okay, T2 is equal to 61 Newton, and T3 equals to 33.87 Newton.